Hello, everyone. We'll be starting shortly with the introduction to C++ programming. If you haven't already, please use the link or the QR code to let us know that you came to our meetings. That way, we have a way to gauge how people are interacting with these general body meetings. And also, as a heads up to everyone here, this general body meeting is being recorded, so you'll be able to find it on our YouTube website after this. And yeah, so you're more than welcome to put any questions you have in IEEE general chat or to unmute yourself and ask them during the presentation if you have any. Although there are going to be many slides that sadly we're going to have to only skim through, or I'll have to ask you to look at the slides later to find out, because learning a programming language is a very dense topic and is hard to cover in a short amount of time. Okay, so looks like looks like a decent number of people are here so far, so let's get started. Okay, so first off, these are a list of all of the various topics that we're going to be covering in these slides. Now, there are a lot, and like I was saying, because learning a programming language is such a dense topic, we're not going to be able to go super in-depth on all of these. And there are also plenty of other topics that are not going to be included in this presentation. Things like operator overloading, recursion, and plenty of others are just not going to be fit into this just due to time's sake. And we will definitely make sure to at least touch on all of these things as we go through, though. Okay, so first off, what is C++? C++ is a very versatile programming language that is modeled in a way that's referred to as a C-style language, meaning any language that's based off of the C language. And one of its unique features that differentiated it from C was that it has the use of classes that allow for object-oriented programming. Now, this programming language is pretty old. It was made back in 1979, making it around 50 years, but it is still widely used to this day. The original name of this language was just C with classes, for like some fun trivia facts, and it actually wasn't a programming language of its own. It was just an addition to the C language that instead became its own language. The C language itself was actually built off of 3 different languages: Algol, BCPL, and B. Okay, so up first, we're going to talk a little about syntax. In all honesty, we'll be covering syntax throughout the entirety of this presentation. But here are some basics to know. Syntax is basically the grammar of the code you write. But some things that you definitely need to make sure you remember is that you pretty much need a semicolon after every line of code that you write. There's very few exceptions to that. You can also use a double forward slash, or this combination of a backslash and asterisks to create comments. And then the other main thing to know going into this is this. This is called the main method. Granted, these 2 parameters in here are completely optional and only needed if you want to give your program files to interact with when you call to run it. These are two examples of the comments that were mentioned before, and this is a special statement called the return statement. We'll cover all that more later, but just know for the time being that having return 0 at the end of your main method tells the program that it finished executing and ran successfully. Okay, so including libraries is a very big benefit in C++. You can use this include macro in the ways that are shown below to include code from other files that will allow you to pull from things that have already been written while writing your own code. The standard libraries are very useful to pull from because they've all been tested very rigorously. Although you can also include files that you've written yourself. Okay, so there are 5 main data types used in C++. The first is the integer or int data type. This data type uses whole numbers ranging from around -2 billion to +2 billion. And if you're noticing that it looks like it stores one less positive number than it does a negative number, that's because it actually stores the same amount but counts 0 as one of the positive numbers it stores. The next set of data types is the float and the double. These are numbers that have a decimal point, which are also referred to as floating point numbers. So the float is a single precision floating point number, which takes up 4 bytes, and the double is a double precision floating point number, which takes up 8 bytes. Basically, the only thing you need to remember for this is that when regarding rounding errors, a double will have a greater precision than a float. The next data type we'll cover is the char. This is an individual character. It could be A, B, etc. Any of these would count as chars. However, there are also a special set of characters called escape sequences. For example, this escape sequence here, the \n character, tells the program to print to a new line. Meanwhile, this one, this next one, the \t, tells the program to put a tab space. And then this last one, \0, is referred to as a null character. And then this Wikipedia page has a list of all escape sequences which in C and C++, which you can check out later. So now then, the next data type is the string data type. And I forgot to mention this before. However, you need to include this, the std : before using anything you include from the standard library. That's just how you identify to the program that it's from the standard library. There is a way around this, which we'll be covering in the demo, though it is generally considered to be sloppy programming. The way to identify a string as opposed to a char is that a string will be put into double quotes while a char will be put in single quotes. And a string can be multiple characters long. The last data type we'll be covering is the bool, or the Boolean. This is named after Boolean algebra and it can be set to one of 2 values, true or false. All of these data types, excluding strings, are also considered the primitive data types, meaning that these are the most basic data types you can use in your program. Okay, so up next, we're going to talk about variables. Variables are like a bucket you can store data into. C++ uses something called strong typing or strict typing, meaning that every variable can only have one kind of value stored into it. So if you have a string variable, you can only put strings in it. If you have an int variable, only put ints into it, etc. Unlike in math, where you have just letters from various alphabets or variables, in coding, you are encouraged to use more descriptive variable names. It will help you understand what your code is doing. These are some examples of things that would be viable variable names. And one thing to point out is that I included in here num apples and no oranges as an example, because both of these are common shorthands I've personally seen for ways of representing number of whatever the thing is. There are a couple rules for when creating your own variable names. They must start with either a letter or an underscore. They cannot contain a space or a special character, like an emoji, for example. Though, from what I've heard, there are special versions of C++ that actually can do that second part. And it cannot be what's referred to as a reserved word or a keyword. This is any word with a reserved purpose, with such as int, double, any other data types, as well as other keywords we'll discuss later, like for, while, class, void, new, return, and etc. This website will give you a list of all keywords in C++. Okay, so next, actually creating the variables. As I said, C++ uses strict typing for its variables. So you have to identify the data type for the variable as well as the variable name. You can, however, declare multiple variables within a single line or a single variable in one line. In this case, this would be 2 integer variables, 1 double variable, etc. The way that we store values into these variables is using something called the assignment operator, which, despite having a scary name, it's just the equal sign. You can use the assignment operator to add values to your array either as you're declaring it or later on in the code. One other thing to mention, a value that is what you're assigning into the array, like in these cases, these zeros, are referred to as literal value. Oh, and also, just for reference, throughout this entire presentation, I'm going to be using mostly integers for my examples, but all of these things will apply to every other data type. Okay, so next up is arrays. Arrays are a special kind of variable that allows you to store multiple different instances of the same kind of data. Accessing each position in the array is done using these square brackets as shown here. And arrays are zero indexed, meaning that if you try to access the element at array index 0, that will get you the first element of the array. Meanwhile, if you use array index 1, that will get you the second element, and etc. and so forth, with the final and fifth element, in this case, being at index 4. Now then, if you create an array using this kind of notation only, then it will create an empty array. These 5 values are not initialized to anything so far. And then you can use all these things down here to perform these operations of assigning values to them. However, there's another way to define arrays shown down here. Up first, we have this is an array literal value, which would create an array of 5 numbers depicted right here into the variable nums1, which this would be how we would represent it. And this would be the equivalent as if we had put a 5 here to declare the length of the array. However, because it just has the literal value, that is unnecessary. However, looking at the next 2 examples, it's possible to give an array length in the square brackets for when creating the variable, and that will cause all of any spaces that are not identified in the given literal value to be added with a well, in this case it would be 0, but for other data types it would be a equivalent of 0 for that data type. For example, a character would be initialized to the null character, and a string would be initialized to an empty string. Okay, so up next, math operators. I'm not going to spend much time on this slide. I think you all know how addition, subtraction, and multiplication work. Just remember to use the asterisk for when multiplying numbers. Okay, however, we are going to have to spend a little time on division. So looking at this code, your base assumption based on math would be that, say, x would probably be 1/2. Meanwhile, y, since x is 1/2, divided by a fraction is multiplied by the inverse and stuff. So y would become 6, right? And then for z, that would be 1/2 divided by 6. That should be 1/12, right? Not at all. Actually, on the second line of this code, we would get a division by 0. The reason for this is because all of the values x, y, z, and the numbers used are all integers. So that means that the division they perform cannot produce any sort of decimal. Granted, if these numbers were either floats or doubles instead, then this division would work completely as normal. So integer division is the kind of division performed on two integers, either variables or literal values. What this effectively is it will divide the two numbers and then just drop the decimals and just round down to the nearest whole number. However, there is a counterpart to this called modulus division. What this does is it'll perform the integer division but return the remainder value. So going to look at these examples, 12 divided by 3, 12 is a multiple of 3, 12 is 4 times 3, so the return value is 4, and because it's a multiple of 3, there will be no remainder. However, doing 13 divided by 3, that would be 4 1/3, but since we drop the decimal place, this would just be 4, and we would have a 1. Okay, so some other frequently used math operators are things like plus and minus, which are used to increment and decrement variables by a value of 1. And there is a little trick to using them where if you put them before versus after a variable, then they will execute at different time. For example, in here, if we do plus x and assign that to y, then x would be incremented before it gets assigned to y. However, if we do x plus plus, assign that to y, then x would only be incremented after the value of x gets assigned to y, which in this case would mean that y would end up being equal to 1, but x would equal 2 after this executes. These 5 operators can be used to assign a value to something that also performs an operation on that value. The example of this here is that here we have y times equals x plus 2, which would be the same thing as if we typed y equals y times x plus 2. So as I mentioned above with these two operators, there is an order of operations for how things are executed called operator precedence. This Wikipedia page has a list of all operators and what their precedence is. Oh, wrong button. Okay, the next thing we're going to cover quickly is data streams. These are your basic ways of getting information in and out of a program. The 3 main data streams that you get from including IOStream are cin, cout, and cir. Cin is input, cout is output, and cir is output for error messages. These are examples of how they're used using these 2 stream operators. This operator is used for output, and this one is used for input. A good way of thinking about it is that in this case, cout is talking to you, and in this case, you are talking to cin. Okay, so now we're going to take a look at a really basic coding example for how to use some of the things we talked about. So then, this is a basic CPP file that I'm going to be using for this live demo. And a CPP file is just a file that stores C++ code. So the first thing we're going to do is add a few include statements. Would help if I could spell, though. So the first thing we're going to include is the IO stream. IO stream. That will allow us to use cin, cout, and cir. The next thing we're going to include is the string library. This will allow us to use string variables. There are many other libraries you can include beyond these, but these are the only ones we're going to be using in this live demo. Now then, the trick for not having to write std : before every string and also every cin or cout or cir you type is to type this using namespace std. As I mentioned before, this is considered to be sloppy programming because this means that your program is going to assume that anything it sees is from the standard libraries, but this can reduce the amount of code you have to write for each to call things from it. Okay, so now down here we have our main method without the parameters since we're not including them. Oh, and also I guess as a brief mention, these are examples of comments, with this being a header comment, which is something that most professors will ask you to include whenever you submit code. Okay, so first thing we're going to do is one of the most simple codes that most people make the first time they ever code. A hello world. Okay, so this thing that I just typed, end L, this is another thing that you would have to normally add the std : to, but because of this, we don't have to. And what this does is it means that it will print a new line character after it prints these characters. Another way we could do this is simply just by typing \n. Okay, and so here, let's take a look and see this code run. So if you haven't been on here before, this is the GL server. And to compile any sort of C++ code, what you have to do is you have to type G++, then type the name of your C++ file, and then if you want, you can just hit enter. Now, this will compile all your code and put it into the file a.out, which you can then type in here to have your code run. However, there's another way you can do this that will allow you to specify what file the executable will be saved to. That's using the -o flag. From here, we can name the file it gets saved to, for example, live demo. So now to run the code, we can just call live demo. Okay, so going back to this code, there also are other data streams that we can use. For example, we can use cin to get the value of something. In this case, let's get a string, which for time's sake, I'll just call str. And then let's have it tell us what we typed to it. Okay, so let's see if this worked. Okay, it worked. Now, as you can see, there was a weird thing that happened here. That's just because I forgot to add an endl to the end of that statement. So all this input and output stuff is nice, but there's a lot more we can do with coding as well. Comparison operators allow us to compare the values of either two variables or even two literal values, or a mix of the two. These are the 6 main comparison operators to determine if it's equal to, not equal to, less than, greater than, less than or equal to, and greater than or equal to. And one of the main ways that these are used are in conditional statements. A good example of this is the if statement and the if-else statement. What this code will do is it will determine if this value would equate, if this expression would equate to true, and then if it does, it will execute this code. In the if-else statement, if this does not equate to true, then instead of running this line of code, it would run this line of code over in the else half of the statement. It's also possible to expand or nest these if statements to have if statements inside of if statements, or to have the else of an if statement be another if-else statement, or just an if statement. There's another kind of conditional statement called a switch. This tends to be a more compact way of an if-else if statement. This is an example of how one might work with an integer a, where basically every case that we have here would basically say, determine if a equals whatever the case is. So for case 0, it would determine if a equals 0. You can also do things like this to have it determine if a would be equal to 1 or a would be equal to 2. However, you need to include a break after every case unless you want execution to continue. So for example, down here, we have case 3 start, and then there's no break, and then case 4 will start. That means that if case 3 or case 4 gets called, if case 3 gets called, it will execute all the code that will be here, as well as the code following case 4, because there's no break here. The default case here acts the same as an else statement, where if a is not equal to any of these values, then just the default case will be run. Okay, so next we're going to talk about a little bit of Boolean algebra. There are 3 special operators that are used to determine if multiple expressions will determine the truth of multiple expressions. These are the not operator, which is an exclamation point, the and operator, which is 2 ampersands, and the or operator, which is 2 pipes. These pipes are, you can type a pipe by pressing shift and the button that should be between the enter key and backspace on most keyboards, or to the right of the square bracket. There is an order of operation for these Boolean algebraic expressions. Specifically, things that are executed in parentheses will be done first, then it will evaluate all not expressions, then all and expressions, then all or expressions going left to right. And these are examples of how each one would be used. Wrong one. Okay, so now we're going to do something based on the input. So in the case of this, so in the case of this, let's make it so that way the program will print out an error message if we type in certain things. For example, how about, since this is C++, let's have it so that if you type in the name of another fairly common coding language, like say Python or Java, then it will return an error saying that you've got the wrong programming language. So we can do that by saying if str equals Python or str equals Java, then that should let us separate it so that way it will only print out what we type if it's not equal to one of those 2 things. And then we can use cerr to print out error, wrong programming language. Okay, so unless I typed something wrong, that should work, and it'll let us do something based on what we type in. So if I type in Python, we should get an error message. Yep, we got an error message instead of printing out what we typed in. And once again, I forgot to add the new line character. Okay, so going back on the slides, there is a little more basic stuff that we can cover. So up first are functions. Functions are a special section of code which can be written outside of the main method that can be run from the main method or any other function for that matter. The way that you run a function from somewhere is you type the name of the function followed by the parameters it uses. Now, every function has 4 common parts. First up is the return type. This is the value that would be returned to wherever it's called after the function is running. And if it doesn't have a data type that return, this is replaced with the word void. Up next, the function name. This is what you type to call the function. The parameter list is a list of variables that the part of the program calling the function has to give the function in order for it to run. And finally, the function body is the actual code run by the function. These are usually broken down into 2 parts, the function prototype and the function declaration. However, there is a way to get around making a function. So first, a function prototype. This is just a simple 1-line explanation of what all the things associated with the function are regarding the return type, the name of the function, and the parameters. What you're doing when you create a function prototype is telling the compiler, which is the part of the computer which prepares your code to be run, that this is a function that I will be filling out and making available to you at a little later in the code. There is a way to get around this, and that would be to actually create the other part of the function we'll be talking about later, the function declaration, prior to any instance of you actually using that. Meanwhile, if you have a prototype in place, then that would allow you to use the function anywhere between the prototype and the declaration, in addition to just being after the declaration. There's one thing to note, that you can have 2 functions with the same name so long as they are overloaded, which means they have to have a different number of parameters or different data types or data types in a different order, which here you can see an example of that between the integer sum function between 2 integers and the float sum function between 2 floats. Both of these would be called the same way. The only difference is that this function would be called if the 2 values presented to it have decimals instead of being whole numbers. And then there's also another thing to bear in mind, which is that in the function prototype, you do not have to specify the name of the variable that you're including. An example of this down here, which is another overload example, is this sum of integers that takes in 5 integers, none of which have their names identified yet, and will return the sum of all of them. And then these are some examples of other kinds of functions you can display. With this example down here, a void function. This would be something that would not contain a return statement and would return some value. So as far as declaring a function, the first part of it would be equivalent to the prototype, assuming that you added the names of the variables. And then after that afterwards, that would be followed by these curly braces with the code that would be run by the function in between. You would also add the return type in here. And it is also worth noting that this is not the only method for having the curly braces. You can also have this curly brace being on the beginning of the next line, which is something that I'm showing on the next slide. It's also a good idea to add a comment with a more detailed explanation of the function at the function declaration, and a comment with a more simple, short and brief to the point explanation of what it does with the prototype. So this is an example of the sum of two integers functions that we had on the prototype page, along with them being called from the main method. So in here we have this. We just return the sum of these two numbers, and this is being called up here, where num is being set to the sum of the values 2 and 3, which means that num will equal 5 after the call to sum of two integers. Brief thing to mention on scope and return values. Because of scope, that means that in this example, from the main method, we would not be able to access the num1 or num2 variables, along with any other variables that we create within this function. Those variables can only be accessed within this function. And similarly, we cannot access the num variable within this function unless we pass it as a parameter. And even then, we're not actually accessing the num variable, we're just accessing the value within that variable. The reason for this is because these two parts of the code are in different scopes. There is, at least that's what they're referred to. There is one scope that both of them have access to called the global scope, though, which is basically where any variable you store outside of the main method or outside of any other function would be in. It is also worth mentioning that the value which gets returned from a function, you can only return one of those values. So you can't return like 2 integers from the function, or at least there's no way to do that from what we've covered so far. Okay, so one other briefer word on methods. Methods are almost identical to functions. The only difference between a function and a method is that a method is associated with some class. We'll be covering what a class is later, but beyond that, there is no real difference to how you define methods and functions. Okay, so the last, more basic thing we're going to be covering is loops. Loops are loops are something that acts almost like an if statement, but the difference is that it will let you run the code multiple times. For example, here we have 2 versions of loops. This first one is called a while loop, and the second one is called a do while loop. The way a while loop works is that it evaluates this when it begins running, which in this case, I is equal to 10. So I is greater than or equal to 0. So it would print out I and decrement I to 9. Then this process will repeat, constantly decrementing I after printing out every time until eventually I would reach -1, and then this while loop would stop executing. The do while loop is a very similar version is very similar to the while loop, with the only caveat of the code that is in the loop is run one time before this condition is evaluated. The one thing you have to remember is that you have to add an extra semicolon over here. So now then, these are a little long. You have to type out basically 5 lines of code for either of these. However, there's a much shorter way to do both of these that only has 3 lines of code using something called the for loop. For loops excel at performing lines of code that are meant to be run a set number of times. They're broken down to 3 parts. The first is the assignment. This is where you create the variables you're going to be using to determine if it's time for the loop to finish running. Next is the condition. This is how you determine when the loop should stop running, similar to the conditional in the while loops. And then lastly, we have, in this case, a decrement value, although it could also be an increment if we instead were to go, like, say, from 0 to I is less than or equal to 10. What this is a line of code that is run after every time the loop finishes executing an iteration. So this code is basically the same thing as this, but it allows us to compact all three of these lines of code into just one, which can save a lot of space if you have to do a lot of loops. Okay, so now we're going to look at one last live coding example, specifically one that I have already finished writing, which is another version of the exact live demo I was showing before, but has some of the things that we've mentioned before. So, we've just covered. So first off, here we have a prototype function for one that we can use to test the value of the string. Another feature that we have here is that everything we had before is now within a while loop. This will allow us to loop for as many times as we want to until we type in the word exit. Down here, we are calling the test string function within this if statement because it returns a Boolean, with the test string function being declared down here, where it will first iterate through the string. Oh, and I guess that's one thing I forgot to mention. The way that a string is stored is as an array of characters, generally speaking. Or at the very least, you can access them like that. So what this will do is it will iterate through the array and then call the toUpper function, which is included in the string library. So in normal cases, you would have to type std : before using it. And it will convert any character into the uppercase version of the character. Doing this means that we can test regardless of case, which means that we could have Python be written in all lowercase letters. We could have just the Y be an uppercase letter, etc. No matter what, it will be caught by the statement and will return the correct value for it. So I guess to check out how this does, since this is just called demo.cpp, I'll just delete that. And then let's run. Okay, I'll do it that way instead. Okay, so now it's asking. Oh, and that's the other thing that was in this that I hadn't included. It's generally useful to include a cout function cout call that helps people know what to type in. So from here, if we type in Python, it tells us that that's the wrong programming language. If we type in Python with an uppercase letter, it still will tell us the wrong programming language. And if we just type in exit, then it'll let us exit. I know I actually didn't really demonstrate this, but in the prior code we had been using, if we had typed in Python, for example, then it would know that it was the wrong programming language. But if instead we had typed in Python with a uppercase letter, then it would not recognize that as being a faulty case. And the same would be true for Java. Okay, so that demo example is being shared with you in the code. And so now we're going to try and quickly cover some of the more advanced topics. Up first, pointers. Pointers are a kind of variable that allows you to reference other variables, essentially. The way that they're declared is by adding an asterisk between the data type and the name of the variable. But you have to remember to include an asterisk for every pointer you want to declare as a pointer, because in this case, pointer1 would be a pointer, or ptr1 would be a pointer, but ptr2 would just be a regular integer. The way you assign the value, the memory address value to a pointer is by using this ampersand here. So ptr equals ampersand num would assign the memory address of num into this pointer. One thing that's worth mentioning is that the way you dereference a pointer is by using this asterisk as well. And by doing this, line right here, we will actually change the value that is stored in num. So another important thing to mention with pointers is something called dynamic memory allocation. This is a special process. Oh, this is a special, yeah, it's a special process that allows the program to not have to worry about creating special places to store memory before the code runs. The way that this is mainly done is by using the new keyword and the free function, which both interact with pointers. The new keyword you combine with a data type, and it will return a pointer to an instance of that data type, which you can then store. And the free function will free the memory that was allocated by the new keyword, and will basically ensure that you don't keep access to code you shouldn't have access to when your code finishes. Another useful way of making sure you don't access data you shouldn't have access to is by setting pointers to null when you're done using them. A null pointer is basically a pointer that points to nothing. And in the case of in the before case, if the new keyword cannot reserve any more memory for you, then instead, in returning you the address to somewhere you can use, it will return you a null pointer. Okay, so next we're going to quickly talk about the 3 custom data types. Up first is the enumerated values, or enum. Basically, the way that you declare an enum is by using this kind of format where you have curly braces and then the values in here. Effectively, all of these values are just assigned a number. In this case, Jan would get number 1, Jan would get the number 0, Feb would get the number 1, March would get the number 2, etc. And you can use either the word used to declare the enums up here or the number to identify which number you're using. The next custom data type we're going to cover is a struct. This is effectively just a collection of variables you can all access at the same time. In this case, this struct date includes an integer for the day, an integer for the year, and the enum from the previous slide for the month. The way to access the values of a struct is using something called the dot operator. What you just do is you just type the name. I'm sorry, I can't words. This is the way that you can interact with an instance of a struct. You just put the name of it, dot, then the member of the struct that you want to access or use. In this case, we're assigning a value to. So in this case, we're assigning the 6th of October, 2020. So this would be tomorrow, actually. I got the dates wrong. Oh well. The last custom data type we're going to talk about is a union. Unions are similar to structs in the way that they're declared. However, the difference is that the union can only store one of these values at a time. This is the closest C++ gets to the other version of storing variables called weakly typed variables. C++ uses strictly typed variables. However, other programming languages like Python, for example, use weakly typed variables where you can store any value into a variable, and it doesn't have to be a specific data type. However, we can access all of these variables within here the same way we did for struct, just we can only access one of them at a time. If we try to access a different one than what we put into there last, then there's no way of telling what it would be. Okay, so the next one we're going to talk about is classes. This is probably one of the most important things to know about C++ because this is the thing that makes it different from C. The fact that it has built-in classes. So the best way to think of a class is as a blueprint for creating something called an object or an instance of that class. Good example of this is that if you wanted to make a house, if you wanted to build a house, then you'd need to get the blueprints for a house. Classes are generally distributed between two files. First is the header file. This will always be a .h file. These are some examples of potential header files you could have, with this being just a really general thing. This being a header file for a person class, header file for a car class, and header file for a list class. This file defines the general structure of the class. After that is the class body. This will be a CPP file or a C++ code file. This is another really general example, but this would be a class body for the same person class as mentioned above, the body for the car class mentioned above, and the body of the list class mentioned above. This is the file where you completely finish filling out everything that you put in your header file. Okay, so first, the header file. This is roughly equivalent to the prototype of a function. And this part is called the class definition. Unlike functions, there is no way, unlike functions with their prototypes, there's no way to skip the class definition in a header file. Although it is possible to include the declaration of methods inside of the class definition without having to do them in the class body like you would otherwise. This will contain all method prototypes and variables that will be a part of the class. And the content of the header file can be broken down into two sections, public and private. This is an example of a person header file that I typed up quickly. And in here you can see there are two sections, the public section and the private section. Everything in this public section is things that can be accessed from outside of the class. This would be things like methods that you call from instances of the class, which we'll cover a little later, to also variables like the ones from structs. After that, there is the private section of the class. This is things that can only be accessed inside instances of the class itself. And this right here is an example of putting the body of the method inside of the header instead of declaring it later on. Okay, so the class body is where you define all of the methods and anything else for the class. To do this, you have to use something called the scope operator. We've actually been using this the whole time with the whole std : The scope operator is just the : So to do this, what you have to do is you have to define that you are accessing the method getName within the scope of the class person. If we hadn't defined the getName function within here, then we would have to have this code somewhere in our class body. There are three special methods that we're going to actually be covering a little more, called the constructor, the copy constructor, and the destructor. And this is an example of what a class body might look like with basically just code stubs for the constructor, copy constructor, and destructor. Okay, so first, the constructor. This is where you initialize all of the variables in your class. There is a constructor auto-generated for every class you define. However, the problem is that this constructor is completely blank. It will do nothing other than just creating the object. A really useful thing for doing in the constructor is assigning all your member variables, which are the variables you would generally just declare in the private section of your code, of your header file. Just as a side note, a common convention is to include any member variables with the prefix m_. So in this case, also the constructor has no return value, but can have as many parameters as you want. And you can also have different constructors with different numbers of parameters. So the next thing we're going to cover is a special kind of constructor called the copy constructor. This is the constructor that's called when performing an assignment from one instance of a class to another. The way that this works is that you have to use this specific function, this specific method name, to create it using the const and the ampersand for the variable, which we haven't covered. We're not going to be covering what those do, but those are very important with the const effectively, so you cannot adjust the values of them, and this ampersand making it so that way you can access them directly. Well, access the object them directly. Once again, a copy constructor will be auto-generated, but the problem is that actually a lot of classes can't really work with this one that well. The way that the copy constructor works for basic values, like we have for mName, mAge, and mHeight, where all they are is just these simple primitive data types that are being stored by the function, not by the function, by the class. If that is all you have, you don't need to create a special copy constructor. They will work perfectly fine on their own. Like the auto-generated one will work perfectly fine for you. The problem comes in if you have any sort of array or any kind of pointer. Within this case, we have an example that is supposed to be a dynamically allocated pointer. In this case, you have to make sure that you go through the entire array. In this case, it's an array of 5 integers, and assign the value of each array directly. Otherwise, you will just be inputting this array into this one, for the reason of arrays operate very similar to pointers. Down here, we have another example with, once again, pointers, where we create a new int, which gives us a value for m pointer, which we dynamically allocated as an integer that it will reference. And then we have to make sure that we dereference m pointer and assign to that the value of the dereferenced m pointer from the them instance of the class. Okay, so last thing we're going to mention is the last of these special methods is the destructor. This method, once again, might not always be needed like the copy constructor because there is an auto-generated version, but it is absolutely crucial if you have any dynamically allocated variables in there. The way that the method is written for the name is it's always a tilde, which is this little squiggly thing, which should be above, well, it should be between the tab key and the escape key on most of your keyboards, and is followed by the name of the class and has no parameters or no return types. This is the last method called by a function prior to the instance of that class being removed completely, whether that's from your code finishing execution or a instance before with dynamic allocation where you free a variable of one of these classes. This is an example of a destructor for the person class we've been mentioning so far. mName, mAge, and mHeight do not need a destructor because they are all just primitive data types. mArray from the copy constructor would also not need to be in here because it does not have any dynamic allocation. But mPointer is dynamically allocated, so we have to make sure that we free it and set it to null in the destructor. Otherwise, this can cause a memory leak. So some other common methods to find in classes are getters and setters. We actually saw an example of this earlier with getName. What these are they're just variables that they're public methods that let you set the values of private variables or get the values of private variables. Another common kind of method is called the helper method. This is a term used to describe any method that is only used to help the class do something else. These kinds of methods are generally private methods, and it's also possible to have a helper function. It's just that would be a function that helps another function do its job. Okay, so we're not going to be able to go too deep into a lot of this stuff just because we are now over time. But inheritance is another thing that C++ allows with its classes. This allows you to define a class as having a parent class or a child class. What that means is that you will be able to effectively reduce the amount of code you have to write for the child class by saying that the child class will have all of the methods, all of the variables, etc., that were defined in the parent class. There's also other relationships you can have, like a grandparent, grandchild, a sibling, etc., which are as you would expect. However, every child can only have one parent class. But while a parent class can have multiple different children classes, which allows for the whole sibling relation. The way that you define a class as being the child of another is through code such as this one, which would go into the first line of your class definition in the header file, for instance. What you have to do is just add this as a class student in this case, because we're doing a student class child of the person class that we've mentioned before. You would have class student : public person. What this will do is it will allow the student class to have access to every method, every variable, etc., that we declared in the person class's header file. So this means it would have access to get name, which we included in the header file. It would also have access to all of the variables from person, which would be m_age, m_height, and m_name, along with any additional variables it chooses to create. There is an important thing to remember for the constructors. You need to include all of the values from the child class specifically, as well as all of the values from the parent's constructor in your constructor, with this being an example of a prototype for one. And you can call the parent's constructor to assign all of the values if you want to, using this notation, where you just put the values of the parent, you just put the parameters for the parent function's constructor in between these curly brackets here, or you can also just assign them as you would normally. So the last thing about inheritance that we're going to talk about is polymorphism. This is something that is a pretty dense subject. We're not going to be going very deep into, but a general explanation of it is that what this does is that it allows you to refer to children class as the parent class through pointers. One big use for this is that you can store instances of various sibling classes, for example, in an array for a parent class, or you can store different classes in an array for one class, so long as that class the array is for a common ancestor of theirs. There is a lot more to this, but for time's sake, we're not going to be going into it. Okay, so next we're going to briefly talk about a very simple data structure called the linked list. The way that this works is kind of similar to an array almost, with the difference being that it is generally implemented as a struct or class that has two values in it. It'll have the value that you're storing in it, as well as a pointer to another instance of those nodes. It's also possible to have a doubly linked list, which will have two pointers in it, one pointer to the next node of the list and one pointer to the previous node of the list. This is a general explanation. I encourage you to read on your own time for time's sake. But over here, this is another thing you can include from the standard library, the list thing, which will work perfectly as a list. And will be a doubly linked list, actually. Okay, so next thing I have to mention regarding the std list class is template classes. Basically, there are some classes like data structures, for example, where you don't know what kind of data types you want to store in it when you're creating the class. And the way to get around having to create a version of the class specific to every different data type is by using a template class. Once again, for time's sake, we're not going to be covering how to make a template class, but the way to use a templated class is with this. In this case, the std list being the example. What you do is you have to include the data type that's being stored by the list in between these greater than and less than signs following the name of the class itself, which would be std list. And you can include any data types in here, even custom data types or classes that you create. Okay, so this is just some basic information of how to add, remove, and read the values in list from the standard library. Push front and push back are used to add values to the front or back of the list. Pop front and pop back will remove the first or last element of the list from the list respectively and remove data type. And this remove function will remove the first instance it finds of whatever value you put into here. For reading items in a list, the best thing to use in that is an iterator, which has this very scary looking definition, but it is very efficient for being used in like a for statement, with this being an example of how you would declare one by just typing in this with its name and then calling the .begin method on your list object, which will return an iterator to the beginning of your list. And so from there, you can increment through your list and dereference it almost as if it was a pointer to go through every value of your list, and then we'll stop executing once the pointer becomes equal to the pointer at the end of the list. There's also some other functions like similar to begin and end that you can use to say, for example, go through a list backwards, but those functions are not included in these slides. Okay, so now we're going to take a quick break because that's all of the content for C++ stuff that we're going to be covering, to look at some stuff for the project we'll be giving you. Here, let me neaten this up. So then, in this case, all of the code that will be part of the project is in the file driver.cpp. I typed that wrong. I forgot the name now. There we go. So this is the file that will be made available to you. But first, let's run it and see what it does. G++. Just pretend that's driver. You'll understand why in a second. And okay, so now then, we've created the project. And now let's take a look at what it is. So this is what the project is. It basically allows you to create and manage any team of your choosing. We can also call various functions to it, like, for example, the count team members function that tells us how many team members are currently on the team, and also the list team members function, which, because there's no one in this list, the list of team members should be empty, but when we try calling this function, we get a seg fault. So, seg faults are very annoying errors. The problem with them is that the code, it is very hard to tell what went wrong with the seg fault, because all you know is that you tried to access memory you shouldn't have had access to. They are infamously hard for figuring out what caused it. However, there are some tools available to us on the GL server that help us figure this information out. So for our debugging portion, we're going to be briefly covering how to use Valgrind and GDB, a general debugger. Valgrind is one of the best tools for trying to get some information on seg faults, though even then it's a little hard to understand at times. And GDB is a useful program that allows you to step through your function, step through your code and see how things are executing. A brief note for GDB, it is very recommended that you should set the TUI flag with the -TUI when calling it, so that way you can actually see the code that's being executed. Okay, so an example of this, well, for the first one, we're going to be using Valgrind to see what went wrong in our project executable. So this is Valgrind. This is just some basic information it prints out at the beginning of anytime you call it. What we care about is when we do the same thing that caused a error before, it will dump out a lot of information at us about what went wrong. In this case, the information that's most relevant to us is going to be towards the bottom. All of this mess up here is just tracing back where the error came from. However, what we care about most for this is this part right here. So in here, it tells us that we had a signal 11 seg, which is just the technical term of saying there was a segmentation fault. And looking through here, we can figure out where the seg fault happened. So for example, this line tells us that it happened because of something that ran in the main method of this project executable. And then this tells us that it happened in the list members function of the project, which this is great information and all, but there's actually a little more information we can get by changing how we compile the function slightly. What we want to do is we want to add a flag, the -G flag. Oops. What this will do is it will basically let Valgrind have better information about the function that we're running. So once again, just doing this. And so now from here, we get more information from it. Specifically, we get that from main, the error occurred on line 43 of the function. And from list members, the error occurred on line 87. 87 of the actual, what's the word? Of the file debug.driver.cpp, which I intentionally left an error in to show this stuff as opposed to the actual driver. So another way we can look at this is by using GDB. We're going to make sure to set the -TUI. And so what this does is, we have to continue here. And setting the -TUI lets us look at all this information, the code that's actually being run. If we didn't have this, or if we used the command disable TUI, then okay, I did that wrong. I'm not sure how to do it. Okay, so there is a way to disable it and enable it from here, from within here, but in a lot of ways it might be easier to just add the flag. So what we can do is, since we know the error is happening on line 43 of the main function from Valgrind, we can say breakpoint, which is B, at line 43. This creates a breakpoint here, right at the call to list members. So because of that, we can also just choose to create other breakpoints. For example, we can say to create a breakpoint directly at list members, which will automatically create a breakpoint right there. We can also create another breakpoint at line 87, because that was the line Valgrind told us the error was being caused by. As you can see here is only 2 lines after the breakpoint created for list member. Okay, so now we can run the code by just pressing R. Or for all of these, you can also type them out, but they also work if you just abbreviate them to the first letter. So now, you'll find that we can just go through this perfectly fine and not encounter the breakpoint until we actually select option 3, which reaches the breakpoint. So at this point, what's useful is to create displays, which abbreviated to D, of the relevant information. In this case, let's see what kind of things we want to display. Well, I guess one thing that would be useful to display would be what is team right now. Let's use the step, which is S, and this will tell us what team is currently evaluating to. So that's not really helpful. That's just telling us what type of variable team is. And that just caused some very weird stuff to happen up here. Okay, so that's not all that useful to us, actually. But another thing that might be useful is the list function. Oh, the list option. By typing L and a number, this should print. Okay, let's try that one more time. Please hold for difficulties, which I guess this is a good point to, wrong thing. Good point to mention, you can always type help to get help for how to use this. Okay, so in this case, we should be able to do this to get information about using the list. Oh, okay, so this gives information about how to use list. I'm still not sure what happened up here, but I don't think I can get rid of that right now. So that tells us that we can just type L. And, oh, I see. So normally it would display it up here, but that's having issues. Okay, well, I'm sorry. This was not supposed to go quite like this. Oh yeah, sorry. This. Okay, so oh well. So I'm afraid this didn't work.
Can you hear me, Sean?
Oh yeah, I can hear you.
Yeah. What might help is if you scroll up a little bit, it might help clear out some of the text jargon. I dropped it in the chat, but yeah. Use the what's it called, the up and down on the keyboard because you're using Windows. So that actually moves the cursor up and down in your code.
Oh.
So it'll help you clear out all that jargon up there.
Oh, there we go. Okay, that was what I didn't realize happened. Okay, thank you.
Yeah, no problem.
Okay, so so in that case, the list function we actually don't need to call. That is pretty much one of the only ways to access information if you don't include the -TUI. So then, from here, let's see. Let's see. Where do we have our breakpoints? Okay, well, I guess I'm not too sure what happened, but we can just type C to continue on to the next breakpoint. Here we go. We found a breakpoint. So now we actually know what's going on, and it'll display it. So from here, we can see that it looks like the error is being caused right here at std cout and dereferencing an iterator for the list. Now, I actually know exactly what is causing this error because I wrote the code specifically. The problem is that right now we are trying to dereference a null pointer. This is one of the most common things that causes a seg fault, or at least it's one of the common things that causes a seg fault. And sometimes you can actually recognize that that's what's happened by the information the Valgrind gives you. However, in this case, it gave so much extra information that I didn't know where to find that. So now that we know where the problem is and like on what lines it is, we can quit out of this by just typing quit or Q. Oh yeah, and it's also worth mentioning you can also use K to just end the program from running without actually leaving GDB. So now that we know where the problems in the actual function are, we can go into this, scroll down to where we found the function. We had the problems on line 87, and fix the parts of this, which in this case is just that I changed this from equals equals to a not equals to an equals equals. And then it will print out the correct stuff, which we can see by running this and use Valgrind just to double check to make sure everything worked. And now if we call 3, this should actually work. Yeah, and it shows that we have an empty team. And now we just choose 0 and exit for now, just to go back to the slides. And the other thing it tells us is that this had no memory leaks. A memory leak is caused when you have a dynamically allocated variable that you forget to free. Valgrind will tell you where that happened. Okay, so now, actually, I guess we just did that. Okay, so the project. This is the very last thing we'll be talking about at all, and this is just a pretty simple-ish project that would be kind of on par for difficulties concerned as like a project that you might get earlier on in 202. Probably not the first one, but so what it is that for the project we provided the file driver.cpp. Driver is a name frequently used to describe a CPP file that contains the main method. For this, you can, with this file, it is an application you can use to create a team of anything. It can be anything you want: a soccer team, a Quidditch team, basketball team, esports, baseball, superheroes, rugby, etc. And it'll let you interact with that team. Specifically, what it'll let you do is it'll let you add and remove members from the team, list all current members of the team, and count the number of members on the team, which was the things that we should do before. So then, these are the 4 different things that we're challenging you to do with the project. The first thing is to try and represent the players in the project as either an object or a struct, as opposed to just a string. Just bear in mind that you will likely need to change a lot of the things like in there regarding how the program will list all of the list all members of the team, so that way it doesn't just print out what the class of, or the name of the class or struct is. It'll actually print out the information of it. Similar to the problem you were having before when I tried using display on the list team. For a class, you'll probably need to create a header file and class body. And for a struct, you can get away with just creating a header file, or you can even just create the struct within the driver file. And you'll also have to alter the list team so that it can store the. The next challenge we have for you is to change the code so that you can create and manage multiple teams at once. The implementation of this is up to you. However, these are some recommendations and that we have that you can use for adding it. The next thing that we have here for a challenge is making so that you can have teams compete against each other. Granted, you'll have to complete part 2 in order to actually do this. And how you determine the winner is completely up to you. But one thing that I would recommend is using the std_rand function from in this library, which will randomly generate a number. It's guaranteed the number is going to be greater than some value. I think it's great. It's something much greater than 3,000, but the exact number that it'll be set to is going to vary drastically depending on your computer, operating system, version of C++, etc. However, there's a pretty simple formula here for creating a random integer that's between 2 numbers. And then the fourth challenge for you is to alter the code again so that you can have a large number of groups compete in a tournament. Once again, how you do it is up to you, but we all, once again, would recommend using the whole rand stuff. And you're also going to need to complete part 2 before this. Completing part 3 will make it easier because you can call the functions that you used for 3 as a helper function for the tournament in part 4. But whether or not you choose part 3 is up to you. To do part 3 as well is up to you. Now then, very important thing to not forget. You're all students first and foremost. Do your schoolwork before attempting any of these projects. They are more important. You're not being graded on these. And so, yeah, thank you all for coming. This is the attendance link. If you didn't get that earlier at the beginning of the meeting, please let us know you were here so that way we can track that information. And this is the GitHub repository that has the driver.cpp file along with the demo code shown today and a copy of these slides. Granted, you can also access these slides by clicking on the link in the email that we sent out when announcing this presentation, which if you need to access, which if you don't have access to, then one way you can get on a mailing list is actually by filling out this link, by just going to this link and just filling out your name and your email address. And then, but yeah, this is the GitHub repository that will access that. And these slides are available on our Google Drive, which you should have a link to from that email. And then here's also some additional resources because we could not cover a lot of stuff in detail at all, and we're already about a half hour over time. But yeah, all of these are very useful sources, with most of them also being available on our website. Well, links to them being available on our website. I would highly recommend checking them out if you have other questions. Sorry, here, Zeke, I'll go back so you can see that. And there's also a QR code on the first slide if that would be better for you. But yeah, thank you all for coming. And also for those of you that stayed the extra half hour that this meeting wasn't supposed to go. And yeah, that's the end of today's meeting.